Thank you. My talk is pre-operational performance of NCMRWF coupled model system. So, next, our objective is to develop a coupled NWP data assimilation and forecast system with the assimilation of atmospheric, land, ocean, and sea ice observation. And we also look at the performance of this coupled NWP system during the cyclone and some heavy rainfall case, or how the impact of the coupled NWP data assimilation system. So coming to this, our NCMRWF, we run the different models. For example, the regional models, these are the 1.5 kilometers and 4 kilometers. Then come to the global models that are 12 kilometers and global ensemble models that is also 12 kilometer range. And if you see the right hand side, the initial condition for the regional models, we use from our downscaling from the global models. And global data assimilation system, we are running a hybrid 4DR, and ensemble system we are also running. And all these models are boundary conditions are from the Austria SSC for the global and regional models. So in a upcoming, we are planning to move with a couple data assimilation systems. So here the atmosphere is 10 kilometers and ocean is 25 kilometers. And these are the future plan, but we run the system. So these are the 4 different components of the coupled NWP systems. Ocean models is from the Nemo ocean model, and assimilation cycle is at 3DR FGate. Our atmospheric model is the unified model, and that is running from hybrid 4DR. And land surface model is Joules, and sea ice model is the CICE, and that is assimilation cycle is 3DR. So we do 2 months of sensitivity tests for this coupled NWP system for the June, July, August, September 2023. And we also carried out around 2 months of data assimilation and forecast cycle for the June, July, August 2024. So if you see the weekly coupled data assimilation system, these are generating the analysis of atmospheric, land, ocean, and sea ice at 6 hours. And we are performing the 4 assimilation cycle per day. And background is obtained from the previous coupled model forecast. And if you see the lower part, these are how the weekly coupled data assimilation systems are performed. All the models, they take forecasts from the coupled models, and initial conditions are generated from the atmosphere. Independent data assimilations carried out, and the ocean has an independent data assimilation system, but the background is coming from the coupled models. And we generate the initial condition, and that initial condition is used for the operational forecast for up to we are producing up to the 10 forecast. So these are the various meteorological and ocean observations we obtain from the various sources. For example, the surface, upper air, and satellite observation we obtain from the GPS. And some of the satellite observations we receive from the NOAA, and a few these satellites from the UMEDCAS. We also receive the observation from our Indian satellite INSAT 3D imager, sounder, and agro-AWS data. And we also have some research related activity. We obtain some data from the state level agency, for example, QSAT, they produce the SC radar, Navy, they provide the wind profiler. So this data is used for validation and research purpose. So now if we come to this our global and observation network, we receive in previous slide we saw the various observation, conventional and satellite observation. These observations are passed to the OPPS. This is observation pre-processing system, and this are further quality control using the observation processing system. And this all observations are passed to the data assimilation system, and that produce and that use the models and produce the analysis and output. So coming to this ocean data assimilation system, we receive the different observation, for example, the surface, altimeter, satellite SSC, ocean sound, and sea ice observation. All the observations are first the quality pre-processed and convert into the offshore format. This is basically required for the quality control of ocean observation. So we first convert all the observation into the particular format for the quality control of the ocean observation. So this is a similar to the atmosphere case. We receive the different observation from the different sources, so that are coming from the wide range of type ASCII data, buffer, HDF. So this all the data are converted into the proper format. It is offshore format, and then that is used for the quality control of this atmospheric observation. These are the recent upgradation in our NCM global DA system. So previously we use only atmospheric model. So here if you see all the system, the pre-processing upgradation in our pre-processing system, then variational data assimilation system upgradation, and this is the land surface upgradation, and this is a unified model upgradation. And the future upgradation is moving from the atmospheric model to the coupled NWP model. So this is some of the details about the model. See, it is from the unified model 11.9 version, and it is 10 kilometers. And the assimilation is incremental 4D var. And if you come to this land surface, it is coming from the joules, and the soil moisture we use as initialization of land surface model. And over the ocean, we have the NEMO model. This is the 1/4 degree, approximately Orca quarter degree resolution, 75 vertical level, and the 3D var FGate we use. And all the 4 components are coupled with the OSIS coupler. So these are the various category-wise of satellite we use for the assimilation radiance that is coming from geostationary polar satellite, and satellite AMV that is coming from geostationary and polar orbital satellite. Then we also assimilated scattermeter wing and GPS RO observation. So this highlight points are the Indian satellite we assimilated in a case of radiance and satellite AMV. So now coming to this estimation, we carried out 2 months of experiment during the June, July, August 2023 and 24. So during that period, one cyclone Ramel. If you see the black line is IMD base track, and different colors are the cyclone track for the different initial condition. And the left hand side is from the couple model, right hand side is from the our atmospheric only model. So in this case, if you see all the cyclonic track are aligned with the base track IMD observation. In the atmospheric model, we have widespread and it's mainly moving away from the observed track, especially over the eastward. That movements are there all the track. So we look at the more details why it's moving eastward in the atmospheric models and not in the couple model. So we found that initially when the cyclone, if you see in the 19th May initial condition, day 6 forecast, cyclone already crossed in atmospheric model. It is showing that it is around the coast, eastern coast of India. But in couple models, the intensity is lower than it is still in the central, around the central Bay of Bengal region. And we come, if you see the 21 initial condition, day 6 forecast, now the cyclone is moving northward and it is reaching over the Bangladesh region. But in the couple model is slightly westward compared to the atmospheric models. So this is persisting in the next 22 May initial condition, also similar situation. And one thing we can also observe that the intensity is lower in the coupled DA compared to the atmospheric only model. In all the initial condition, if you see the 19, 21, 22, and 23. And right hand side is shows the base track of the IMD provided. We now evaluated the three different parameters, the direct position error and along the track error and the cross track error. And we found that for this Ramel cyclone case, initially we have couple models are having the less position error compared to the atmospheric models up to 72 hours. We can see that then after that both the NCM and atmospheric models and couple models having the similar kind of error. So further we saw the steering flow of atmospheric models and the couple models. So this is the analysis of couple models. Lower part is the analysis of atmospheric model, and the right hand side is the day 5 forecast of the couple models. Lower one is the day 5 forecast from the atmospheric models. So here we saw that main difference is the intensity. If we see the couple models are predicting well, it is along the track, and the circulations are also aligned with the track only. But if we come to this atmospheric models, it is showing much more intense and moving away from the track, observed track. And this mainly because of the lower branch that southwesterly are much more stronger in the day 5 forecast of the atmospheric models that are not, it's not seen in the analysis. So this is one of the main reason for the staying away from the cyclone in the atmospheric models, not in the coupled system. So this is the another cyclone Biparjoy. This is this cyclone is in Arabian Sea, and the cyclone is longest. It's around 7 days stayed over the oceanic region, and its positions are also we can see almost in a straight case up to 7 days continuously. But in this case, we have much spread are much more in the couple, and the atmospheric models are aligned with this same position as observation in this case. So we look at now for the Biparjoy case, what are the rainfall intensity, and this is during the 8th June and 9th June. The first part is observed rainfall. This is coming from the GPM. Center one is the couple NCM forecast, and right side is the atmospheric only model. So Here we see that the intensity, if we see the rainfall and intensity that is predicted well in the couple NCM, we can see that however the spreads are, if we see the spreads are relatively less in this couple models compared to this atmospheric only model. Then we look at the 2 months of rainfall. First one is for July. This is for 1 month, July 2023, whole July, how the rainfall in the observation. Lower part is the day 1, day 3, day 4, day 5 forecast from the atmospheric only models, and lower part is the couple model, day 1, day 3, day 5 forecast. And right hand side is for the July 2024. Upper part is the observation. Middle part is from the atmospheric model forecast, and lower part is from the couple model. So here we observe that over the equatorial region, the atmospheric models are overestimating from the day 3 and day 5 forecast. If you see the overestimation, and that will reduce in this couple model case. And similarly, if we see in the 2024 also, similar kind of over the equatorial region, we have strong rainfall band patterns observed from the in forecast day 3 and day 5 forecast. That is not there in the couple models, and so couple model focus is well over this region. Over the Indian region, we do the bias case, and we saw that the bias is relatively less over the equatorial and poor monsoon zone, especially over the central India region. Compared to the atmospheric models, the bias is less. Now coming to this model skill, we evaluate this model skill in terms of probability distribution function, false alarm rate, ETS, and bias. And here we saw that the skills are not much affected in day 3, day 5, day 1, day 3, day 5 forecast. But we saw that in some year we found that the ETS are improving compared to these atmospheric models, but that is not case in the 2024. So we cannot say the each time couple model perform best. So here we found that in 2023 we have better ETS compared to the atmospheric models, but that case was not in the 2024. It almost both are showing the similar ETS. So now the 10th July is the case when the heavy rainfall over the northern part of India. And first one is observation, and this is atmospheric models, and lower part is the couple models. So we saw that rainfall, the heavy rainfall pattern, day 1 and day 3 forecast. Couple models are predicting the performance seems slightly better, especially that the heavy rainfall pattern of this case. So overall, we saw that there are biases less in the couple models compared to the atmospheric model, especially over the oceanic region. And we found that the cyclone Ramel case, we observed that the errors, both direct along track and along the track and direct errors are less in compared to the atmospheric models. And here we put it one condition why the reductions are there in the oceanic region. So we have not plotted this VIMT. This is vertical integrated moisture transport. But we saw that this reduction in the bias is because of the good representation of vertical integrator of moisture transport in the couple models. So that plot we here not included, but we saw in a result. Thank you. If you have any question.
Thank you. Thank you for the good presentation. And are there any questions from the audience? Let me just quickly check. Okay, so the first question is by Lars Neger. You talk about the different assimilation schemes used for the atmosphere, the ocean, ice, and land for different components. Do you have any plans to unify these assimilation schemes?
No, not now. Actually, we are now working on the weekly couple data simulations. Once this weekly couple become operational, then we further move to the strongly couple. So in that case, we include the covariance and those part also into the account. So now both the systems are independently running, atmospheric assimilations are running independently compared to the ocean data assimilation. So in future, we are moving from the weekly to the strongly coupled.
Yeah, okay. So this weekly coupled is the current work, and you also turn to the strongly coupled thing, yeah. Okay. And the second question is from Fei Prong. Have you done any impact studies on ocean observations influencing tropical cyclone forecast in your system?
Not now. These are the pre-operational testing, so we have not much look at the ocean case. But we are now also looking the how the each increments are generated into the ocean and their impact in the atmosphere. That we are now looking into. But
Yeah.
still now we are not showing that oceanic assimilation impact.
Okay. And last question from Hyun Soo Kim. The ocean coupling would produce better tropical cyclone intensity forecast. And have you done a comparison between validation for the tropical cyclone intensity forecast?
Oh, intensity we have not looked at, but we saw that from the plot, the intensities are less compared to the atmospheric model. But we are not verified against the observation. So here we saw that the intensity in this case, that MSLP, if you see the MSLP are left hand side is from the atmospheric models and right hand side this side is the couple. So we saw that intensity are less in that couple model. But we are not look at which one is better and how much error with respect to the analysis or other observations. We have not looked at that part. But we can definitely say that the couple models intensity is less compared to the atmospheric only model in this case.
Yeah, okay. I think there's no more questions from you, Pat. And well, I think I have very simple questions from your side. So you mentioned in this slide observation, so you mentioned many types of different observations from different sources. So I'm just wondering, so do you have any consideration on, so for example, if you have the same observation types from different sources, so how do you do this selection or optimization? So how would you like to use the different sources of the same types of observation? Or it is not a problem actually, so there's no such kind of overlaps.
No, we have same type of observation. We are coming from the different satellite also. For example, INSAT 3D they provide radiance. Similarly, Meteosat is also provide the radiance in same region. So that may be this both the observations are going into the assimilation cycle, and then assimilation will decide which observation has more weightage. So that will be taken care by assimilation cycle. But we provide whatever observations are coming from the different source, we just packing and we are putting into the assimilation system.
Okay, yeah, then yeah, I see. Okay, thank you.
Yeah. Thank you.